Hey, college algebra friends. Hope you're doing okay with 7.1. So I'm going to do my best to get us going with 7.2. This is the best way I have at the moment to give lecture notes. I'm at home, so I had to find something to write out so you could see. So just to get you going here, I've uploaded 7.2 to Google Classroom. I really hope you've joined that to get the information. I've given you 2 copies, a blank copy of the questions as well as a copy of the notes where I've worked them out. Just like you would if you missed class, I would have handed you my notes. But what I'm going to do is go through each question on this video and work them out. So the best thing you can do to actually learn the topic is to follow my video and fill in the notes as I go over the examples, just like you would do in class. And I'll do each problem, but this video may be a bit long, so I may have to split it into a couple of parts. We'll just see how it goes. So just bear with me and we'll see how far we can get. So the first question, hopefully you have a copy of the notes or you're looking at the notes while I'm going over the questions so you know what I'm talking about. First question talks about depreciation, and we're given an equation that says V equals C 1 minus R to the T power. And so what we're doing, we're just applying those exponential functions that we worked with the other day. Well, let me just tell you what everything stands for. V stands for the value of the machine. C stands for the original cost. And R stands for the rate of depreciation. Well, depreciation is just where after you buy a product like a car or any type of machine or whatever, it's going to lose its value over time. And so we want to know what that percent of depreciation is going to be. And then T just stands for how many years we're looking at. And so the question says, find the value of the machine at the end of 5 years. So T is my 5. And then the original cost, well, this is C, was $1,439. And so the question says the rate of depreciation was 0.3. Well, that means 30%. 1 minus 0.3. So basically, I'm just filling in the numbers they give me, and I'm going to stick that into my calculator. So right here, this is just an example of what we would call exponential decay, because this number right here that I'm going to circle, this is like our base from our graphs. It's going to be less than 1, so it's going to be 0.7. So you just stick this in your calculator and you end up with how much this particular machine is worth after 5 years. And so the value I end up with is $241.85. And that's all you're doing. So hopefully that one wasn't too bad. Hopefully you have your calculator with you. Second question talks about the concentration of a drug after you take it in your bloodstream. So let's say you have a headache and you take an ibuprofen. How much of it will be left in the bloodstream after so many minutes? And so hopefully you're reading the question. Here's the formula that they give us. So the cool part about this assignment is they give us almost every formula. Only on a couple of them am I going to have to actually create the formula. You just need to plug in the values. Now this one looks a little tricky, but he's not hard. I just need to talk to you about it. So the concentration of a certain drug in a bloodstream after T minutes. So this little guy right here is my time, my minutes. And here's my formula. And so this is like it's talking about the rate of increase, the rate of change here. But this little guy right here, 1 minus, again, that's defining that I have decay. It's spreading out throughout my bloodstream after so many minutes. And I need to remind you that E comes into play. Okay, hopefully you remember E from Algebra 2. E is a number. It exists on your calculator. It's roughly 2.71828 ... It keeps going. So he's such an important number. He's like pi. He has his own symbol in the calculator. And so if you can't find E, you might have to hit me a text on Remind, and I'll try to help you find where E is located, like show me the face of your calculator, and we'll try to hunt him down. But most calculators have it showing. But all you're going to do is substitute in the information they give you. It says, what's the concentration after 14 minutes? And it says round to 3 decimal places. So I'm just going to stick this in, 1 minus, we're going to use E in our calculator. We're actually going to type it in, 2, and then this is times 14. I kind of ran out of room there. So you're going to actually type all of this into your calculator just like you see it, and you're going to end up getting 0.0188. And it says round it to 3 decimal places, so 123.019 would be your final answer. So it didn't give me kind of like a unit of measurement, but maybe cc's or something like that would be my unit. Okay? The second type of question that we're going to end up doing is interest. So I'm going to have some interest formulas. And there's 2 types of interest that you use. And so you go to the bank, you've been given some money, you're going to go to the bank, and you're going to look at how interest is compounded. So this is not simple interest, it's compound interest. So here's one of the formulas we're going to use. P stands for the principal. That's how much money you start at the bank with. And notice I'm going to go 1 plus. 1 means 100%. And so anytime I am growing, since it's a plus sign, I'm going to be growing. It's above 1. So I'm going to gain money next year and the next year. So I'm going to increase it by 100%. So my formula looks like this: R over N, and then N times T. Now, what do these things mean? Well, R means the rate of interest. N means how often I'm compounding it. And so we have to talk about compounding and understand what does it mean to compound. So when you think of compounding annually, you do it 1 time a year. Biannually or semi-annually, otherwise known as twice. Quarterly is 4, and then monthly, of course, is 12. So they're going to take that money and compound it on top of each other 1 time a year, twice a year, every 6 months, every 3 months for quarterly, and then monthly every month. And so notice the N here is also part of my exponent. So whatever number I put here also goes up top. And then, of course, T is how many years I'm going to leave it in there. Okay? The other formula is compounding continuously. And compounding continuously means I'm using this particular formula. You may have seen it in Algebra 2. It's called the PERT formula. P again stands for how much money you're going to start off with, take it to the bank. E, of course, is the number we talked about a few minutes ago in the previous problem, so it's part of my formula, so it's going to be 2.71828, so that's going to be some type of your rate, your growth there. And then R means our rate again, but just make sure that you're writing that rate as a decimal, because that'll throw you a curveball if you don't. And of course, T is years. Okay, so we'll try to work this first question, and then I may have to change and upload a different video. So here we go. Let's try this first question. Do an example 1. We have Blanche from the Golden Girls. She recently inherited $5,200. So when you think about $5,200, that is your principal. And so she wants to take it and deposit it into a CD. So she's determined that her two best bets are on an account that compounds continuously. So I'm going to do continuously. If I spelled it wrong. And that rate is 2.6%, but I'm going to write it like this, 0.026. And we're going to call that account number 1. And then she's going to also investigate another account. It compounds, daily. I forgot to mention that. Daily, 365 days, at an annual rate of 2.8%. So this rate is 0.028. So I'm going to have to do this formula kind of twice. And so here is the formula for the first one, PERT. So my principal, 5,200. E, and then the rate, 0.026, and we're going to do it for 1 year. She just wants to know the annual rate, or annual time, so that's going to be 1. So sticking that in the calculator, I end up getting this. Now, guys, round your numbers to the nearest penny, because this is money. So this is how much she's going to gain after 1 year. But you see, I want the interest. So I'm going to take this amount of money minus the initial investment, and I end up getting $136.97. So that's how much she's going to gain on account 1. And then over here in account 2, we're doing compounding daily. So remember, the formula for this is P1 plus R over N times T. So 5,200, 1 plus the rate as a decimal, 0.028, over, now N stands for how often are you compounding it. It's 365. Well, that's also part of my exponent, and I'm going to do it for 1 year. Now, the key is to type it in just like you see it. That way you won't mess up your amounts here. So I end up with $5,347.65. So I'm going to take off the initial investment, $5,200, and we see that she's going to have $147.65. So the question says, which account would pay more interest? And so we're going to choose account 2 because she had more money. Okay? And so, and it would say by how much and so forth. So you're going to just see which one. So part B, this is a part A question. But a part B of the question says, how much would Blanche's balance be from account 2 over 3 years? And so that was the one that was compounded daily. So our formula would kind of tweak a little bit, 0.028, 365 again, but this time I'm going to take it over 3 years. Again, stick it in the calculator just like you see it, and we end up getting $5,655.65. Okay. I went ahead and worked out the second compound interest question just to show you what it was, because it's just like one of the first ones. This time I'm not doing a comparison, account 1, account 2. I'm just doing a straight up question. So I ended up with $14,464.01 in the second investment there on number 2. So I'm going to go ahead and work the third question, and then I won't have to stop the video because it might be too big. So I'm going to go ahead and work it. So this is number 3. He's just a little bit different because I'm looking not for money, I'm looking for a rate. So Jose hopes to earn $700 in 2.2 years time from $56,000. There's a little typo on your handout. Okay, just make sure you read that as $56,000 that he was available to invest. To decide if it is feasible to do this by investing in an account that compounds annually. So let me just kind of get that straightened. He wants to have this amount of money when he stops, or when he at the end of the period. But he's going to start off with this. Okay, and he's going to compound it annually. So compounding annually means just one time a year. So our denominator, if I were to make a fraction, would be over 1. So I'm just going to put R, because I really don't need a denominator. Okay, and so if there was an imaginary 1 here, like here, then I'd put the 1 up there. So I kind of don't need it. So I'm just going to leave it as such. And so there's a 1 up top. And then it says 2.2 years is how long he's going to leave it in there. So I'm looking for R. This is a weirder question. Okay, so I just got to get it to isolate it. So it's kind of like having to do that inverse problem. Remember how we worked that in the last unit? You're going to undo what you have. And so basically, this is what you got. I'm multiplying. So I would love to get this parenthesis by itself. So I'm going to divide by $56,000. That way that'll cancel. And I end up with 1.0125 equals, and then that parenthesis just drops. And then 1 times 2.2 was 2.2. Now, guys, this is an exponent. If you want to get rid of an exponent, just think of anything to the second power, I'd take the square root. Anything to the third power, I'd take the cube root. So this is the 2.2 power. So let's take the 2.2 root. And yes, you can do that in your calculator, 2.2. Just like you take the cube root, all right? So when you take the 2.2 root of this value here, I get 1.000566 equals, and then that just drops 1 plus R. I'm going to subtract 1, and I get 0.00566 as my R. Well, the question says, what's the annual rate? Now, I can't type this into the calculator. I have to make it into a rate. So a decimal into a percent, you move it 2 places to the right. So I went 2 places, so that's 0.5, and it wants it 2 places. Again, this part here, 2 places. So I'm going to say 0.57, and then that's a percent. So that's the rate of that he's going to use in order to achieve $700 in interest.